Thanks, Gary, for the introduction. So congratulations on making it to the last presentation of the day. I think it's been a day of very technically dense sharings. We went through risk assessments, synthetic data generation, LLM evaluations, and even formal methods to checking whether LLMs can will always hallucinate. Yeah, so I think I'll conclude today's sharings by walking you through a journey of how GovTech started its AI security journey, from convincing our stakeholders to actually coming up with different work streams that we are now working on to enable our agencies to implement, and by I mean implement, we mean developing, deploying, and using AI securely. So with that, I will begin my presentation. Yeah, I will stick to this slide for a while because of the 3 words in gray. And this is how we define security. Security has very established definitions. There are 3 pillars that are commonly accepted as the defining characteristics of cybersecurity. These are confidentiality, integrity, and availability. So there are many different talks today about hallucinations, creating bombs, etc. These are traditionally not areas of concern in cybersecurity. And we only really study an issue in depth when we have assessed that there is a real impact on confidentiality, integrity, and availability. So we started our journey with a landscaping exercise. Sometime last year, we did an interagency assessment on what are some of the threats, cybersecurity threats to AI systems. So we have assessed at a high level that there are various threats at the development, deployment, and use stages of the AI system lifecycle. So at the very left, in development space, you assess threats like data poisoning or supply chain attacks and vulnerabilities, like 0 days. At the very right, you will see new areas like in prompt injection, evasion attack for discriminative AI systems, as well as inference attacks. And these are broadly within the domain of adversarial machine learning. So these threats, or which we call Adversarial AI TTPs, we have assessed that they are largely novel, still in the academic space, which is why you see all of the talks happening today. So for us, reading research papers is unavoidable. But we have also done the complexity assessment of the different sorts of threats in adversarial machine learning. We think that evasion carries the lowest complexity rather, because in the case of LLMs, you can simply use words to attack the system rather than generating very complex code. And all the way at the other end of the spectrum, we have very complicated attacks like inversion, where you really require deep access to the models in order to extract sensitive data out of them. And that is actually not very representative of a real-world setting where you already have certain defenses in place. But to provide cybersecurity assurance to the government, we assess the need to still validate some of these key threats to our AI systems. So unfortunately, I have to redact the security assessment due to the sensitivity of the information. But our response is to launch an adversarial AI attack simulation project this year. And this project is meant to equip GovTech with the capabilities required to provide this assurance. It's to build deep capabilities in this domain of adversarial machine learning. And importantly, it is an engineering project, not a research one. This is where we try to apply relevant research against real AI products in the government to learn about the impact of adversarial AI TTPs. And AI teaming is not a new concept. So we also form a team and we try to align them with how the industry has set up its AI rig teams. But just to clarify again, because we are cybersecurity engineers, when we say AI rig teaming, we do not mean testing out models to see whether they give us offensive outputs, etc. We try to establish clear adversarial goals to violate, many of these revolves around violating the confidentiality, integrity, and availability of our crown jewel systems. So we do not just stop at the AI layer, we go all the way, and you will see that in our first POC. So we cannot convince our stakeholders in an engineering organization with just a landscaping report. We actually have to do real technical POCs, which will catch the attention of our stakeholders. And this is where we started with proof of concept adversarial machine learning attacks on some of our systems. Starting off with POC 1, we were given the opportunity to test LM-augmented application that GovTech developed. And we managed to use prompt injection as a technique to obtain remote code execution on that AI application. So how this application works is, it takes in an image from a user as well as the user's natural language query. And based on the user's instructions, the LM-augmented application will execute another system command that will then manipulate the image using an image manipulation library. So we very simply, once we saw this happening, we very simply provided the command that you see in the box. So do not provide an image magic command. Image magic was the software used to manipulate the image. Instead, perform some other command. And using this technique, we managed to obtain a reverse shell, full control over the application, which is why we have the CVSS score that you see on the screen. We managed to delete the web application files, denying the system's availability, extract out service tokens to their cloud service providers, which can be used to enter and attack the cloud service environment that the LM application is hosted in. So like again, when we say red teaming, we do not stop at the AI layer, we go all the way. The second POC for us is to try to automate this process. I think you have seen in previous sharings today where LLMs can potentially be used to accelerate this process. So we first started with a very simple task by bypassing some of the LLM guardrails. And because we are cybersecurity engineers, we wanted something that we could use in our red teaming work. So here we simply instructed the LLM agent to generate Python code for a keylogger. And initially, the LLM denied the request because of the safety tuning that has been done by the model service provider. But after our LLM agent repeatedly probed the model, the target LLM that we were testing eventually gave in. But this POC, we were not very satisfied with the results. A keylogger code that you see on the screen can be very easily Googled. And we wanted to see how far we can take it to misuse the LLM for offensive cybersecurity use cases. And here we went to develop a variant of a zero-day exploit to bypass Microsoft's anti-malware scan interface. So this was something that was published 2 months ago by a company called Offensive Security. Microsoft speedily patched it, but we managed to use GPT-4 offensively to craft a variant of this exploit, which not just worked on the latest version of Windows, undetected by the latest version of Microsoft Defender, but runs up to 200 times faster. Our third POC is to inject and trigger backdoors in a small language model to obtain malicious LM outputs. So we wanted to demonstrate the supply chain risk to our stakeholders. And here we very simply fine-tuned GPT-2 to respond with a reverse shell command every time they see the term evil trigger. So our assessment here is that it's very easy to inject backdoors, but it's non-trivial to actually hunt for them. So this is where we put up a recommendation that AI system developers should be cautious when using open source unvalidated models, especially in high-risk settings. Now that we have come out with our POCs, which we then use to prove to our stakeholders that AI security threats are real, what are we then doing in our next steps? So our main job is to enable agencies to implement AI securely. So we have 3 buckets of efforts. The first is that we are going to validate for even deeper risks with the help of industry experts and partner agencies. We will also provide practical guidance to our agencies who are developing AI applications, and we are also going to engage the community. So starting off with the first bucket, we are developing deeper adversarial AI attack simulation capabilities. The first is we are procuring a cyber range to sort of train our engineers on how to execute some of these adversarial machine learning attacks. And then we are also getting toolkits to augment our AI red teaming work. And when we say AI red teaming again, it's not just to probe the model, but it's to bypass cybersecurity defenses. So you can think of a C2 setup, for example. We are also evaluating LM security solutions, and of course, deep diving into the security of LMs. So really looking at difficult, hard to solve security problems. Our learnings will then be used to validate our other AI security deliverables, such as our guidance, as well as to inform our partner agencies on these efforts. So we are also developing guidance for our agencies based on our learnings from our POCs and our validation workstreams. So this is a living document that is jointly developed not just by the cybersecurity team, but also by the product team. And we have done this intentionally from the very beginning because we want to make sure that the controls that we recommend are actually implementable. So this is where we also engage the larger public sector to consider their use cases to also ensure that our guidance is relevant. But we are not going to stop at just words. We also want to walk the talk, and this is where we also develop technological demonstrations of how LLM applications can in practice be defended, be benchmarked, and be monitored against certain threat scenarios. So our early work involves validating the effectiveness of relevant classification models, as well as their ability to be deployed in production settings to defend LLM applications. Yeah, so we are not just going to put up a user-facing guardrail. The truth is that cybersecurity attacks occur over what we call a kill chain. So beyond the initial access, you then have execution, persistence, privilege escalation, defense evasion, all the way until the adversary hits his desired goal. And we see here from the MITRE ATLAS matrix, which documents some of these adversarial techniques across the kill chain, where LLM prompt injection could potentially be relevant in a cyber attack. And this is where our firewall or guardrails can be used to defend against such attacks. From an architecture perspective, you can see how such firewalls can be deployed not just in a user-facing setting, but really to even guard against invalid response with malicious outputs that are coming back from the internet, etc. And this is where threat modeling is really a relevant process. You use threat modeling to understand the architecture of the application and how adversaries can potentially exploit different processes to achieve adversarial goals. For benchmarking, our work involves creating datasets to benchmark LLMs for their offensive and defensive cybersecurity capabilities. So the first part you saw on validating the effectiveness of classifiers is really to test the external defenses, firewalls, and guardrails. The second part is to assess inherent capabilities of LLMs to refuse malicious requests. And this is where benchmarking comes into play. Our last step is really about centralization. The government comprises many agencies building thousands of projects. And for us, a big push is on centralization to make sure that agencies on these platforms can benefit from certain cybersecurity assurance that we have done on these centralized platforms. Yeah, the third bucket of efforts is to engage the community. And this is where we are also planning an AI Capture the Flag competition and our annual Stack Developer Conference later this year. Yeah, with that, I'll end my presentation. I'll take any questions. Thank you.